Hey guys, today we're going to be going over the SAT and ACT math concept known as logarithms. So essentially what a logarithm is I will draw an example here. So this is what a logarithm would look like. The way we would say this out loud would be log base b of x equals y. And essentially what it tells you is it's like what power or exponent is needed to raise a number to another number to equal that number. So essentially it would be written, for example, this formally should be written as b to the power of y equals x. So basically, a log just tells you the exponent needed to make x in this scenario. And it's basically just a way to count multiplication. So I'm going to go to some examples here as this is. So first, we're going to start with number 46 here, which is a pretty basic example of what you might see on these standardized tests. This is definitely one of the more easier questions with logs. So the question asks, when log base 5 of x equals -2, what is x? So the way we would do this basically is very simple. We basically all we need to know is the original form of logarithms. So we would know that we start with this base 5, so we know that 5 to the power of something, right? So knowing from that, we know that logarithms have to equal an exponent, so that's how we know 5 to the power of -2. And this number out here always goes to the side. So essentially, this is our equation, and from here, let's actually parentheses this. From here, this is a very simple equation. We just do 5 to the power of 2, and then we take the reciprocal of that. So we get 1 over 25 equals x, and we get a very simple 1 over 25 with our answer being k, right? Now, furthermore, we're going to move over here to some other logarithm rules. So there's essentially three main logarithm rules that, besides the base form that you have to memorize, which was, I'll write it back here again, equals b to the power of y equals x. The other main rule, the other three main rules is, two of them are represented in this equation. One of them is not. So I'll write the first. I'll first write the one that isn't represented. So essentially, if we have this equation, and this also works vice versa later on, as you'll see what I mean. When we have an equation like this can equal over this. So essentially, we have to keep in mind that this works both ways. So the main point here is that for all of these rules, the bases have to be the same, right? So if this is b and this is y, if this is base b and this is base s, for example, this would just not be possible. So essentially, what's important to remember is this can only work with the same bases, and this can basically work both ways. Whenever you see a subtraction sign with the same base, you can just think of division, or when you see this, you could flip it back to subtraction. Either way, that works. So second off, the second rule that we have with exponents would be known as the power rule. So in this equation, we see that we have uh, log base 10 of 2x to the power of 1/2. We're looking for if x is greater than 0, which of the following expressions equal to this. So the way we would do this is, we know there's a rule in logarithms where when we have an exponent like this, essentially we can move it in front of the logarithm like this and rewrite it in this format. Now this works here um, because it's just a rule. I'd say there's not really any other way to think about it except just memorizing it. These are just, that this is the unfortunate part of logarithms. I feel a lot of the rules are just memorized and you have to practice them and really remember them. But essentially, this is a form, the form that we could also write this in. And as you can see, From these examples, we can already see that, let's see here, this one doesn't have 1/2. Um, and later on, I'll show you another example of why we can cross D off as well. So the final rule that we can include is when we have log base b of x. Actually, let's write it like this: log, log base xy, so x times y essentially, right? If we have log base b of xy, this can be written separately like this. So essentially, these two are also reversible, similar to how we did with the division here. We just put addition and now they multiply. Um, so this is important for us in this equation because, as you can see, if we think about it, if we fully write out this equation, right, log 2x, and on top of that we have these two 1/2s added together. It just doesn't make sense. Thus, that we can cross D out as well. So essentially, knowing all this information, all these rules, right? Knowing that these are vice versa, that these can be done either like in this direction or in this direction, and knowing that the bases have to be the same, we can simplify this equation down, right? First, knowing that we can have 1/2 in front, we can have the logarithm, and we can keep the base of 10. And actually another addition is that, I forgot to mention this, but anytime the base value, like when you look into your calculator, you'll see just log. Log basically just means 10. Log base 10. Like that is the natural original form of a logarithm where you don't have to write anything. Essentially, it's just like when you have 1x, you don't have to write this 1. It's similar to that in that aspect, that it's just the base form of logarithms. But essentially, we know that we can put 1/2 in front of log and log base 10, and we can keep the 2x for now. And from here, it's very simple. We just split this one more time, log, and we know we have the 2, and because this is 2 times x, we can add and split it like this. And actually, now I see this. Actually, split it. They split it the other way, which they would put the 1/2 in front of the log 10 of x, which is honestly also, I think, plausible. I think that works as well, because essentially 1 times 1/2, 1/2 times 1, they're the exact same thing. So knowing that, our answer would be C for this question. And yeah, I think it's just important not to get confused with your log rules. They're very simple, straightforward, especially on the ACT and SAT. I don't think they challenge you too much on logs, make you, memorize very difficult rules. Like um, later on, if you get to competition prep or more difficult algebra, you'll notice that there's a lot more rules to memorize. But yeah, finally, our final example of logarithms will include a natural log, which is written in the form ln. So essentially, a natural log is the exact same thing as a normal logarithm, except it's written using e, which is known as Euler's number. And what e is it's approximately 2.71. And it's essentially like the way to think about it is pi. It's a continuing number. It never ends, and it essentially just shows exponential infinite growth. So the way we use Euler's number in natural logarithms is it's essentially the same thing, right? So when we have the natural log of x equals 4, then what is x? So from the form is essentially just, if we have ln x equals 4, and this is basically just, you have to memorize it. There's not really a very good way to explain it, but we know that um, these type like logarithm questions have to equal the exponent. So 4, we're gonna write 4 in the exponent, right? And it's gonna equal x, because essentially we'd like to think of ln as writing a little e right here at the bottom, just like we do with logarithms. So e to the power of 4 equals x. So In this case, in question 53, e to the power 4 equals x would be the letter E, and that would be the correct answer. Um, like I said, natural logarithms, very simple, very similar to logarithms. Um, they're normally used in finance when you want to calculate continuous exponential growth, with the formula P times E times rate to the power of T. Oh, actually, I'm sorry. P times Euler to the power of rate times, so your principal amount times Euler's number times the rate times the time is exponential continuous growth, and that's something you'll learn in algebra 2. That's just part of the curriculum. And yeah, besides that, I think logarithms are a very simple, easy to master concept. They just require a little bit of practice and memorization, but if you ever see them on your tests, they should be very simple and free points. And yeah, so thank you guys for watching the video. I hope you guys enjoyed, and if you guys have any questions, please leave a comment and like if you enjoyed. So yeah, um, thank you.